Okay, welcome. So this is Saeed Ahmed from Toronto, Canada. This video will be on stock price prediction using machine learning approaches like graph neural network. So we are creating videos on this. Now we actually were trying to catch up where we left. So let me share the screen. So this is the channel. Okay, we're just catching up, right? Catching up. So this catch up, that was the uh, review where we are, and that was mostly on the no coding was there, right? Now I'm trying to see in terms of coding where we are. I think I described it here, but I did not show you the code. So this is one of the model that we worked on. Yeah, I just tried to see if it still works or not. Okay, epochs to test. Yeah, I think I tried just 10 epochs. Okay, so in terms of change, yeah, recently I just changed it, just transposing it, this dot t transpose, and then rounding up to 1 digit after decimal, right? This I did so that I can plot it in the PowerPoint document, I think in a table easily. And also the PowerPoint, it had this. Okay, if you're following it, then it has some values. If not, it probably will not make much sense, right? It used to be MAP was down, MAE was up. I changed it because it will give some help in terms of taking this data, copying and pasting on the PowerPoint presentation table. That's why I did it. So let me see if I share the PowerPoint, then it may make a little bit more sense. Though it's not really that important in terms of coding. But the thing is, if you're following it, if you're following all the videos, then you may see, okay, so RMSC, MAP, MAE, right? Okay, so that's why it was done there, changing it and just so that there is a lack of space. So I just took rounding only 1 digit after the uh, decimal. Okay, so that's all about it. I think I changed it, I think rounding the values here, I think let's say when I was plotting, until this point I was rounding up to 2. That was the original goal, right? But when I saw that, okay, if I try to copy and paste on the PowerPoint, still uh, it takes more space than I have. So I just round it to 1. Anyway, yeah, the next goal is be just reducing these errors and making the prediction correct, right? And if you saw in the PowerPoint, I think RMSE probably is around 12. Probably the lowest I probably got might be 30 or 40. So, like, okay. So that was the simplest model, and just a GCN, right? GCN and MLP. And this one is GCN, CNN, and then MLP. Okay, GCN, CNN, MLP. So yeah, I'm just executing it so that I'm just trying to see if it still works and everything. Okay, epochs 10,000. The last time I ran it for 5,000 epochs, and then I collected the output. I just thought, okay, if I can run it for more epochs, if things improves or not. Okay, I think the uh, lowest RMSE was 39. In the 5,000 iteration, lowest was 5,000. Let me say, might have created some okay, execution PDFs. Hmm, 0417. I believe I created a PDF today. So anyway, I don't see it here, but yeah, let me see. So at least I can see. So 10,000 mean squared error. And there are some gaps. I think the shape is okay, but there are some gaps. Here, percentage error. Okay, validation exceeded. Is the validation perform better than training and then exceeded? So this probably needs some explanation. Okay, train and validation. So validation is becoming better than train. Loss, train loss is high, validation loss is lower. Okay, I think it is not, it does not sound right. Something needs to be checked. Let me see. How does the number look like? Okay, mean square error. No, I think it is in the same range. So nothing improved. Let me see if I try to save it. Where does it save? Okay, I'm not sure why it's okay, let me see. It looks like it's going to the same place. So I'm not really sure if the system had a different time. Unlikely. Okay, it's 1000. Simplest. Okay. I need to save. Where exactly did I save it? Yeah, I'm still trying to see it where, yeah, let me see. I think when I was using this 5,000 epochs, I had a better performance, but this thing I also need to see why. Okay, let me see for the Pycharm. Okay, test matrix, model matrix, right? Now, okay, train matrix and test matrix. Train matrix, mean squared error, test loss. Okay, looks like test is performing better. Mean squared error 16. MAPMAE. So it looks like test worked better than the train. Now train, we need to reduce it. Okay, so that was the second model. I think, let's see. Second model. Yeah, I'm just trying to catch up what it did. And yeah, I believe it is GCN plus CNN and then MLP. The simplest one was only GCN plus MLP. Okay, so this is GCN and then convolutional CNN, right? Okay. And in the meantime, I did change one more thing. I think this matrix, I believe I told, right? So MAP was the last matrix. I just make it in the middle so that it helps with the copy and paste. And to be consistent, somewhere I might use MSC, somewhere I have used mean squared error. I probably could replace mean squared error with MSC. Okay, so let's see. Let's do it right now. Find and replace this with MSE. Okay, the best probably this, so that it changes in the right place. Okay, now let's see Spearman. Okay, before Spearman, I can see okay, this is the Pycharm. Okay, let's see what happens in the yeah, I'm going can delta because just immediately before it will show the plots for okay, train and validation. So am I doing anything wrong? Okay, train loss is high, validation loss is low. I think, yeah, I think as I saw test validation, those are performing better than the train. In general, that it doesn't happen like this. In general, uh, train performs better. So let me see. This is something to candle and then finance. Okay, so I think it probably I need to go down, right? Train loss is low, validation loss is high. Okay, in some way it can be like this, right? Mean squared error, validation is high, loss MAP, MAE. So that is the train, right? Train Okay. So it looks like I need to do the test part, right? Okay, test 84, that is 37. And this is 12,000 test. Training is 2605. I need to do square root, that's a different thing. 53 and 37, 53, 37. This is high, right? Okay, this probably is on another issue. The prediction, all of them are coming the same. This is not what we want because it needs to reflect the individual stock and their prices, right? So as far as I saw that, I believe I saw notes on that. It happens if their connections are too many. Think more connected graph, but this financial news actually was not that that much connected. It was sort of sparse kind of things, but and happening it that it does not seem that right. And tau. Okay, one more thing I need to see when I worked on it. Did I complete that financial part? I believe I did, but still, the result that needs to be uh, verified. Okay. Okay, this is the third one, right? Okay, in third one, it is the Deepgraph CNN, right? Deepgraph CNN. So let's say what is Deepgraph CNN? Okay, so this is what it is. Several GCN layers, that's sort pooling, 1D convolution, 1D max pool, 1D convolution, fully connected output, right? So this is the Deepgraph CNN. So now at the final layer, I'll be using MLP, right? This is also a classification problem. The one that they're doing is classification, mine is regression. So for regression, I'll be using MLP on the last step. And one another thing, these guys, for this third model, what they're doing, it is actually protein graph classification kind of thing. So there are lots of graph. They are training on many different graphs, and then they are classifying them for the test or new data, right? So in my case, what I have just all the one graph of stock relations, right? One graph stock relations. I can testing and validation graph. I can bring that concept, but it's not like I have 10 training graph, right? I do not have 10 training graph that, or let's say not train. Let's say I do not have 100 total graph, where I can take 70 for training, this much for testing. So I cannot do that, right? I have only one thing. So if I want to adapt to my thing into Deepgraph CNN, uh, the simplest approach that I'm trying, because it expects multiple graphs. So one graph for training, one graph for testing, and one graph for, okay, they might be using some validation graph as well. Something is there, I need to see. So I think this classification, I tried to, in this classification example, so I need to see what they are doing. I am doing. So the idea is, okay, I will need to create multiple things. Okay, let's say I was doing one training graph, one testing. Okay, probably for the code adjustment. And another thing, okay, probably some variations of training graph, some variations of training graph probably uh, possible, probably with adjusted close price and the close price. So two variations possible. And another thing is uh, open price and close price. I don't think they really do reflect much. They they may not be all that reliable, but still closing price probably uh, there might have some relation, stock price relations, and then opening price and closing price relations. There may be something. It's not impossible. The stocks, the relationships among their closing price and the relationships among their opening price, it is not impossible to have. Probably we need to see the correlations between these uh, opening price correlations and closing price correlations and see if they're very close or similar or same stock. So we probably can create some more training graph. One is based on open price, one is adjusted close price, another close price, and what else is there? Okay, yeah, that probably can give some clue, some more training graph. Then some of them can be testing and validations. Okay, or even if we don't want to create multiple training graph, probably all the graph that we create, we sort of give the code a feeling that we have separate training, testing, and training graph, right? That way, this graph, Deepgraph CNN can be made working. So that's the where I was last time when I was working on it. So from there, I can take it further. I believe that's what I was trying to do last time. So importing libraries, yes, stellar graph. Okay, I really do not need this. Okay, this is sorting. Okay, interpolating. Okay, I believe there was something that we do not have any data for this stock anyway. So you probably can just remove this column, right? Okay, for Pycharm, that's okay. I also need to remove the self loop, this one, diagonal one. So this is the train. Okay, I'm using some stocks as a train graph. Okay, I'm trying to do it in the regular machine learning statistics graph. I believe graph training testing slightly works differently. Okay, it may not be impossible that in graph mining you supply all the total graph in the testing. I think testing data can overlap with training. This kind of concept is there in graph neural network. So here, still I'm separating. I'm just thinking, okay, so let's see if the correlations can, if the correlation has a relation with the pricing. So the way it will happen in training, the same way it can happen in testing. That's the idea. But another way, I told that one another variations can be using the opening price, one training graph, using the closing price, and then we do some sort of testing. Okay, let's say this is probably the training graph. So this is the testing, and this is the validation. Train correlation, okay, train graph, test graph, and validation graph. Okay, that's good. GCN layer, I think I'll be following the Deepgraph CNN, right? That's similar structure. Unless if I need, wherever I need, I will change it. Okay, that's okay. Okay, it is about, I believe, because I'm using some library method. So I need to supply all the different node and all the different age and stock price as part of the node data time series data. I need to supply it. So that's what I'm doing here. Okay, this is to separate to the stellar graph. Okay, so yeah, this is the node data. Let me see. Okay. But this is the time series data. That's okay. Train test split. Okay, I believe I need to change it from here. I believe. Last time when I was working with it, but that's where I stopped in train test, because this approach was before when I had just the only one graph. I was using that one for the as long as train subjects, test subjects. No, I need to change it so that it reflects the new approach. Previously, I was trying to one graph using Deepgraph CNN, but it looks like Deepgraph CNN, it works differently. It needs multiple graph. So okay, this is the Deepgraph CNN. Okay, this is also part of this. Okay, I believe I also worked with this. Now I need to see if I did it right. Okay, so I probably was doing those, probably I just ignoring those code and probably using the new thing. I was doing this here. Okay, experiment. Yeah, I was doing something there. Okay, it might be, let's see, probably 10 days or something. I did not do much or any on this project. Or it can be a week at least. Let me see. When was this uploaded? Anyway, it's not important, right? I need to see if the model.fit, whether that works or not. That is the important part. Okay, this is something I need to fix, and then things can move forward from here. Okay, in terms of catch up, so third model that I need to work on, and I need to improve the performance of these two. And I will try to see if I can take this second one, GCN CNN MLP, and convert it into GCN CNN, then GCN CNN, then MLP. That is one of the goal. And third model, okay, it will be interesting to see how the deep graph works. Now, the same data I'm subdividing, creating multiple training graph, or using open price one graph and some other graph, some other pricing, another training graph, and how this thing can really predict the stock market price, right? Stock price. So it will be interesting to see. Okay, so making the second model as close as possible to the paper model, that is one thing important to do, right? And then improving the performance of second model, improving the performance of this simplest model, and then making this third model working and then improving performance. Those will be some important goals, and if we can achieve it, that will be considered as a good success. And there are other ways of doing it. I think other things, I think GCN parcel STM, this configuration prediction, that can be one thing to do, or probably some sort of equations on the very basic matrix manipulation, the way the GCN CNN works, using those matrix manipulation or matrix or math level equation, utilizing those to implement this stock prediction. That could be one thing to do. I think that can get the most tricky thing, but if you can get it right, that probably where you can do or achieve the most or not, but probably that's something good to do. Yeah. Okay, and if you're into finance, try other approaches of predicting stock prices, right? Anyway, Okay, that's all for now. Bye.